Good evening, everyone. Thanks for joining this exciting webinar on LLM evaluation. The title we have put is Essential Measures for Enhancing LLM Trust and Reliability. And we have Pavan here, who is a distinguished guest. I will introduce himself. I will introduce him in just a few minutes. Thanks, Pavan, for joining. Today is a special day, very special day for RagaAI. We have launched our basically RagaAI LLM Hub, which is the most comprehensive LLM evaluation and guardrail suite. So would love to briefly talk about that. And then LLM evaluation is a very interesting, exciting topic. Would be great to hear Pavan's thought on it, who's a leading expert in this area. So let me just give a quick intro of what we have released today. Yeah, so RagaAI LLM Hub is the most comprehensive open source evaluation and guardrail platform for LLMs that has been released. It has 100 plus very focused design metrics for LLM evaluation. It is we open sourced it, but there is an enterprise ready platform which provides scalability, data privacy, and various other aspects like customer support, on-prem deployment. And we are also actually, with this announcement, we're also launching a hackathon with prize money and job opportunities, details on our website. So do try this. Let me just go into a little bit of details of what we're doing on this. So the problem statement is very clear on LLMs, right? It has been a significant challenge to take LLMs from POC to production with a range of issues. Obviously, we are going to focus on reliability, trustworthiness, and security aspects here. Let me start with a few examples. One example, which is very important, hallucination. Right? We know that LLMs hallucinate. Here's an example which was in the news some time back. Using some of the technologies that we have released, we are able to basically address those very effectively. Setting guardrails is extremely important, right? So that there are guidelines and regulatory requirements across countries and industries. And it's important for us to basically address those, right? So the example that we're seeing here. And guardrails is a very important aspect that we are offering as part of this release. And then the right context management for RAG applications, which has been a challenge. So is a challenge as we look at different verticals and industries. And that is something that we are addressing very well in what we have released today. So I was very excited about that. This is a quick look of some of the matrices we have released in 3 categories. First one is RAG evaluation. We are looking at things like hallucination, summarization, correctness, right? Guardrails we talked about, right? So we are looking at PII, sensitive data, sentiment analysis, right? And then vulnerability like right, basically bullying, prompt injection, things like those, right? So it's a very comprehensive 100 plus metrics, right? In one package, which is now available on GitHub for you to use. So this comes with full UI. So I think it's a great opportunity for anyone to basically build on top of what we're offering in the open source world. And as I said, right, we have an enterprise version available for enterprises who want to basically deploy it on their cloud or prem as well. Very excited about this. With that, we would love to basically talk about the webinar today. LLM evaluation and guardrails. We have put the best technology out there that is available. We are putting a lot of effort in building the best technology, but this is an evolving area, and would love to have a discussion on that. And Pavan is a foremost expert in this area, so we are very excited to have someone like Pavan. Pavan would like to switch on your video, please. So let me just briefly introduce Pavan here. So Pavan is basically the director and professor at the School of Engineering at Arizona State University. I've known Pavan for some time, and I've really been excited to see how he has grown in his career, right? A very, very encouraging way. And just to give a little bit about his background, right? So he's a leader in artificial intelligence and machine learning, and leading expert in media content generation using AI. His work was recently presented the title Improving Shape Awareness and Interpretability in Deep Networks Using Geometric Moments, which was at the workshop, which was in conjunction with ICVPR. He has been doing amazing work in this area. He also he's a leading expert at the intersection of GenAI and media arts, right, which is content generation, right? So we'll talk about that very, very exciting area as well. So Pavan, yeah, really excited to have you here. Everyone is looking forward to hear your views on this important topic. So would love to basically learn about your journey, right, in the AI GenAI space, right? I think that would be a great place to start.
Well, thank you so much, Gaurav, for organizing this, and thank you for inviting me. And yes, we've known each other for more than a decade, maybe 15 years now. So it's exciting to also see your growth and where where your ambitions are leading you. So that's amazing. So thank you so much for this opportunity, and thank you all attendees for the opportunity to speak. So my journey into AI is not what might be considered very straight, and it's twists and full of twists and turns. So I am an electrical engineer by training, good old fashioned EE, and I was trying to become a communications engineer when I was an undergraduate. And by chance, I had a chance to do an internship at IBM Labs in New Delhi, which is with IIT Delhi, where I was exposed to this notion of content-based image retrieval. Now, this was back in 2003. And at the same time, I was exposed to this other project going on machine translation, which no one talks about now, but that was the early days of translating one language to another, that kind of stuff. So these were like amazing, unbelievable application areas, which as an EE, you would never hear about in your classes, right? So very quickly, I pivoted. The fourth year of my project, we do this year-long project. I said, I want to do something in image video. And I did some very basic computer vision type of project. And that led me into grad school, into computer vision again. So I was coming in from a very different training. I was coming in from signal processing and statistics, that sort of training. So it took me some time to figure out how people think about problems in vision. And over time, it became machine learning and deep learning and so on and so forth. My special sauce in this mix has always been to go back to the phenomena that leads to the data generation process. And I will keep coming back to that through this webinar and try to express the knowledge of how the data is generated in some tractable form. And oftentimes when we start expressing that knowledge as a constraint, things are not always simple vector space math. Things can become non-Euclidean. And that's where some of my special sauce has been, non-Euclidean constraints and making them amenable to deep learning. And we constantly keep finding that every time we do that, things get a little bit better, things get a little more robust, things become a little more less biased and so on and so forth. And I will mention those examples. So that's my journey. And at Arizona State, I'm in the School of Arts, Media, and Engineering. And that's the school I direct, where we have roughly 1/3 artists, 1/3 engineers, and 1/3 philosophers. So we think about the grand problems of the field, everything that has to do with technology development and how it's applied and what its implication is on society. So I've been here for the last 13, 14 years now, and it's been a great journey. It helps me tap into expertise that I would not otherwise have if I were just in a simple engineering department. I have access to people who think about the human aspects of tech and the human condition, whether that's improving or not improving because of tech. I get access to people who make films, animation, 3D modeling, and how they think about content creation versus how we think about content creation. So it's been a great journey so far. Yeah.
Thanks, Pavan. This is really, really impressive. By the way, if you have any questions, please feel free to write in the Q&A. We will answer those as they come in, and we have a dedicated 15 minutes towards the end for Q&A as well. So thank you. No, I think so. All of us have been enamored by how GenAI and LLMs have just transforming the way that we are moving forward, right? We just like to hear your perspective on how this whole landscape has been changing, right? I think we'll probably start from there.
Great, thanks. So, I mean, everyone, including myself, has been, catching up, really. I mean, the pace of progress is so fast that I don't think anyone has a real handle on how this has happened so fast, but we're all catching up. However, some things have become very undeniably shocking and surprising in the past couple of years. I'll give you a couple examples. Everyone is aware of the Turing test, right? I mean, that's like a very popular thing everyone has heard about. But to me, the fact that a chatbot got close to breaking the Turing test was interesting, but not like things that caught my attention. But the things that really caught my attention were the image version of the Turing test, which far fewer people have heard of. So of course, most of you probably know the Turing test, which is if I'm sitting and chatting with a chatbot, can an average person say whether it's real or not, up to whatever 70% confidence. There is an image version to it, which was propounded in the 1980s by a mathematician at Brown University who goes by the name Ulf Grenander. He's passed away now. He's seen as there is a niche area in computer vision where people talk about pattern theory, pattern generation, and it really began with Ulf Grenander's work, where he said, I think if you want to build a classifier for an object, sure, you can look at the metrics that everyone reports, F1 score, accuracy, precision recall, all that's fine. But the real test for whether you really know what a dog is if you can make a picture of a dog and make it look like it's real or if it's human made. So that was the test he propounded. And it's somewhere in his old books in the 1980s. And when we were in graduate school, very few people had even read those types of books, but I was reading those types of books and was like, looks like the Turing test of imaging will never get broken. Who's ever going to make an algorithm that can make a picture of a dog? But that happened. And that's when I really started paying attention that, oh my God, it's not just a matter of text, but also this high dimensional thing that images are looking real now, videos are looking real now, 3D data is looking real now. And that to me is significant personally. So what I would like to say is, look, the old tests that people had propounded that AI ML has to meet these bars, from my perspective, they are meeting those bars. However, the bars don't have to be met 100% of the times for those tests to be broken. They only need to be met 70, 80% of the times. And therefore, the way they were originally propounded, those tests are broken. I mean, those metrics have been broken. But people still don't trust them, right? I mean, even that 20% errors that we see really undermine our faith and trust in GenAI and LLMs. And we don't yet have proper metrics to assess that stuff. How do we get to the point of understanding trustworthiness? We don't really have solid metrics that we can do a moonshot on.
Correct.
So yeah, I think that's where we are, which is the century-old goals, I think, have been met to the most, to the extent possible. But now we have to make new goals. Yeah.
Yeah. No, I think definitely. I think, and that's what we are going to just deep dive, and that's what RagaAI has been focusing a lot actually on, right? So in general, right, means there are a lot of issues, right? Means obviously LLM GenAI's potential is immense, but there are a lot of issues to basically reach that potential, right? So what are some of the key issues that you see, right, as you basically work end to end, right? And would love to hear your perspective on that.
I mean, the key issues that I see in, let's say, the future growth of these tools is, first of all, we are still very much beholden to one type of methodology that has led to where we have, arrived, which is, of course, neural nets. And I believe there are other methodologies out there which are not seeing the light of day. And of course, let's wait and see. I mean, there is always this big expectation that a new methodology will only be looked at if it's performing at a high enough level. So I think that is an interesting bar to have, but it is also the same bar that withheld the neural net progress for a long 20, 30 years. So I think we should be looking at new methodologies. But despite that, I mean, this reliance on larger and larger models and models layered on other models and models and models, right? I mean, it's feeling like turtles stacked on turtles. I don't know. I mean, there is this very classic philosophical precept that if you ask, well, how does this work? And then you answer it in some way, and then you say, how does that work? And then you keep on going. So it's like turtles all the way down, turtles supporting other turtles. So AI ML is becoming like that. There's models supporting other models and models supporting other models. And if you keep probing further and further down at the very base, to the extent I can trace it down, the base thing is a classification model. I mean, if you look at LLMs, of course, the base thing is a word encoder model. And in the image video things, the base thing is a image classifier model. And right there are the fundamental problems that hold us back when you start building on top of them. In the case of GenAI, for example, we are still stuck with classification and categorization of the world, right? The step one of building a classifier is we say the world is made of objects and objects have names. And right there is a problem. I mean, yes, the world is made of objects, but not all objects have names. And the same objects can have multiple names. And there are many things that cannot be named. Not everything is the linguistic equivalent. So all those things are kind of shoved away for the convenient job of first building a classifier. But once that first classifier was built, circa 2012, when AlexNet hit the scene and was able to classify 1,000 categories really well, things went into a tailspin. And that's the basis of, let's say, the GenAI stuff we see. And if you don't have a category represented early on, those advanced models will also not have them because you keep stacking them on top of each other. So that's some of the problems we are seeing, that the way the world is modeled. I mean, people talk about world models all the time. I am going to say, well, I don't know if there is a world model, but we always start with thinking of the world as made up of discrete things. That in the context of LLMs means we think that all language is made up of 30,000 words, and we only have to figure out how they're put together. And in the case of image and video, we say there's 1,000 things, maybe 20,000 things. So everything is a discrete enumeration of things. And to me, that is a very foundational limitation of these ideas, which shows up in a number of different ways. Will we ever have enough data to train increasing numbers of classes? So the more you think about these things as defined as discrete categories, you're stuck with the data problem again and again. You will not have enough data to train all categories. So then you have issues of bias, you have issues of representation, you have issues of inconsistency, and confusing classes show up. So those would be the real roots of the problems. I personally don't know how to break free from that, but what I would say is there are alternative ways about, I mean, so why were these technologies invented in the first place? These were seen as ways to solve navigation problems. For example, self-driving tech, a robot should be able to navigate a home and not make mistakes. So there were some very practical, simple, bounded problems for which this tech was initially considered. But now suddenly they have swapped into this other stuff like GenAI. Like putting an artist out of business was never the purpose of AI. Right? I mean, making Hollywood style videos was never the purpose of AI, but suddenly it has become the purpose of AI. But the original roots were solve these bounded problems and have these things be meaningful in the bounds that they are meant for, where fine, maybe 20 objects make sense. But when you come out of that thing and say unboundedly that I can make an image work as if it were made by a human, we are stretching the tech. We are not true to the roots of what AI was supposed to be. And we have to acknowledge the limits that in that unbounded way, we can't really describe the world as 20,000 objects. So there is that limitation. And I think that's what I would mention. Yeah.
Great. I think that's a great perspective. I think many of the issues, right, are evolving, right? And as you said, right, I mean, the package that we released today from RagaAI, right? I think we have been addressing many of these issues, right? So I think, but as you said, right, means things are evolving so fast, right? So it's very important for us to understand and go deeper and see, right, how these issues are having an impact and what should be done, right? So I think let's just go deeper into some of the issues that we are seeing in an LLM evaluation and guardrails, right? And let's start with what you said about data set. I think data is one of the most important problem we hear from customer and market today, right? It's something RagaAI has been focusing a lot, right? So golden data set, for example, is a word that has been used very recently, right? Which is, right? So what do you think about how to basically have, what are the right things to do in that direction, right? Yeah. Would love to hear your thoughts. Yeah.
Yes, I mean, this notion of a golden data set to, let's say, fine tune an LLM so that it is available as, so you can also assess, whether it's doing well on that golden data set. I think it's a good direction. That is the natural direction that things should progress in. But constructing that golden data set, once again, will have the same issues and limitations that any data collection suffers from, which is you cannot take you have to enumerate things up front. You have to enumerate what categories you're interested in. You have to enumerate what concepts you're interested in, what failure cases you're interested in. And you have to be very clear that it's bounded in those ways. You cannot construct a golden data set which will suddenly be put into production with no bounds. So this notion of bounding it is super critical. As an example, like working in a big organization, the more I think about it, I don't know, I mean, many of you may know ASU is one of the first organizations, universities that has inked a partnership with OpenAI. And part of that partnership is to promote organizational efficiency using language models. I'm not part of exactly what's being implemented, but I hear about it. And here is what I keep hearing. They want to automate, simple things like bureaucratic processes, which are repetitive, which have, well set defined processes. And they want to test it. They want to test it. Rather than go talk to a staff person about how to fill out a travel reimbursement form, can that be automated? Stuff like that. So the more I think about it, and the more I think about what enterprises suffer from, at the very bottom level, yes, there are simple processes that have been set in stone, haven't changed in a decade. I think those things are prime to be, yes, you can make a golden data set of all possible questions that might be asked, all possible issues that might come up, and it's feasible that it could be constructed well enough. But even for slightly more higher level tasks, the rules change all the time. I mean, organizations are not bound by static rule books. Policies change all the time. Often, every other semester, we have a slightly updated rule on something. And this is often a reaction to what's coming from the top. There is some government policies change that trickles down to the university, and we have to change. There is a very little that I can point to, at least in my organization, that says, oh, here is the rule book that is fixed now for the next 10 years. So that is going to be a challenge in creating these golden data sets for fine-tuning LLMs, except for the very outward customer facing things where things are set. I think we will have a challenge. But again, I think that is the direction to proceed. But how do you construct? How many experts are needed to be in the room to construct a golden data set, even for a very repetitive task? That is unknown. And in an organization as big as ASU, each department has its own slightly fine-tuned rule book. Even though the general rules are similar, every department works a slightly different way. So it might be seen as precision AI, precision tuning at the very small units that you might consider in an organization. I'm not sure if it would be easy to make a golden data set at the top level of the organization. Yeah.
Thanks a lot. No, I think data generation, golden data set is one of the key issues that we see in the industry today. At RagaAI, we're working with, we have some amazing technologies on that, working with many leading customers. We have not talked publicly about that, but soon we will, yeah. So I think that's something that needs to be addressed very properly, right? Next topic, hallucination. Everyone is talking about hallucination, right? And it is a real problem, and it's not very easy to address those problems, right? Right. So I think for us to make sure that LLMs and GenAI is giving the right output, right? How do we address the issue of hallucination? What are your thoughts on those?
Great question. I think so. If we look at the spectrum of what GenAI is doing, if you look at the different types of media and different types of hallucinations happening in different types of media, my instinct is there are different things we need to do for different media. In text, the types of hallucinations we see are very different than the types of hallucinations we see in image or video and sound and so on and so forth. And here is what I've been noticing. So we have a class here in ASU, which I teach. It's called Machine Learning for Media Arts, which is where we explore all these ideas through student projects. We just let them, we teach them how GenAI generally works, and then you pick up tools, and then you test it out in different ways. So what I found is this. Yes, hallucinations are a thing. People understand that. When it comes to text models, they are being used in such a different array of applications that it's hard to say how to deal with it across the spectrum. Is it simply conversational things, or is it actually as a code assistant? Is it actually as a multimodal, Q&A situation? So people are using LLMs in a very vast array of things. It's very hard to say how to deal with hallucinations at that spectrum. Mm-hmm. But I think the answers typically tend to be that you have to bound. You have to keep asking it, why do you say this? Why do you say this? And explain your thought process step by step. That is one of the tricks that I've seen people employ, at least on the user side. On the development side, it's not clear, right? I mean, on the development side, if things just go out of whack, what can the modeler do? There is, of course, assessments on golden data sets, which may be feasible. But as things progress and become more complicated, I suspect people will have to train another type of model to detect things going out of whack or detecting hallucinations. Very much like how deepfake tech has evolved. I mean, there was this whole period 3-4 years ago where detecting a deepfake was its own problem in its own right. And I
Right.
think that will happen. I mean, detecting hallucinations in LLMs will become a problem in its own right. And I think that will have to be addressed. But then the issue is, who creates the training set for that model? And then again, do we go around getting several users to actually adversarially test it and then flag all the hallucinations, or do we synthetically generate it? What is the golden data set for that problem? So again, all the same questions will appear again in that format. But I think that's the direction. We have to have yet another algorithmic solution to detect those hallucinations. Otherwise, everything is patchwork. For a very specific type of hallucination, you can put a little guardrail. But I think the longer direction would be automation of that as well.
Mm-hmm.
But when it comes to other media, people are finding a different type of solution. So we have, students who want to make games with ChatGPT, for example. We have people who want to make little animation with some other OpenAI tool, like, Sora, for example, or Runway ML, for example.
Yeah.
Uh, and sound has its own use cases. People want to, convert a little dialogue into actual sound signal, and there are many other tools that are out there, like Google Magenta project is out there. What I've been finding is this. The tolerance for hallucinations is different in different media. Uh, People tend to tolerate hallucinations in image much more than sound, for example. Meaning, if you see someone with 6 fingers, people will tolerate that, versus even a little glitch in the sound signal that you generate through a GenAI tool will be flagged as, oh, that shouldn't be there. So our tolerance levels are different, depending on the different sensory stream we are using it
Mm-hmm.
to process.
Mm-hmm.
So image and video, people tend to be okay with fake stuff.
Mm-hmm.
uh, and the guiding principle in Hollywood is the same thing. If you talk about how visual effects works, the goal of visual effects is not to make everything real. The goal of visual effects is to make things real selectively in those areas where people are going to pay attention, but there's going to be this huge background of things where things may not really be real. That is like a known guiding principle for visual effects. So from that perspective, GenAI may actually be tolerable as a solution in the video generation aspects. When it comes to sound and music, no. I mean, no, there is no fakeness anywhere. And people are extremely sensitive. Our ears have a way higher sampling rate than our visual sense. I mean, that's the signal processing person talking. Sound is 44 kilohertz. Vision, 1 megapixel is too much for us. So we are extremely sensitive to certain media compared to others. And people will have different ways to deal with that. Yeah.
I think this multimodal aspects is very interesting, and the way you have brought in you have shared your views and your expertise on different modalities, right? And that's very interesting as well, right? And you mentioned about guardrails. I think that's another interesting topic, right? Means would love to go deeper into that. By the way, for hallucination, means the package that we have released, we have really good technology we have offered there, right? So I think, but as you said, right, this is an evolving area, right? So this will continue to evolve, the new technologies and new approaches, right? Yeah. So coming on to guardrails, as you said, right, it's another very important area to ensure GenAI and LLMs work properly, right? We want to make sure that output is not biased. It's not giving out sensitive information like PII, right? It is basically doing the right thing while running in real time, right? That is becoming a very important topic, right? To ensure that LM is and Gen AI is basically doing what is intended to do, and not it should not be doing what it's not supposed to do, right?
Right.
Love to hear your thoughts on guardrails, right? Right, and your perspective on what you have seen.
Yeah. Thank you, Gaurav. I think, the first set of solutions that I'm seeing with respect to setting guardrails is, detecting, the usual things, detect hate, detect, harmful, questions, detect illegal behavior, detect. Also, there are these other things where, which are not really in the guardrails business, but how do you know that? Can you cite a source of information? Can you find the truth value of an assertion that an LLM makes?
Mm-hmm.
Of course, there is the RAG approach, right? The retrieval augmented generation, where you do have people are expected to, put in a document, and then you should cite the source of where it's coming from. So those are the first set of solutions that are going to be interesting when it comes to setting guardrails. I'm also seeing interesting things like people say, okay, how do you protect against prompt injection? How do you protect against, like the do anything attack? How do you guard against that? And the final word is not yet out, but I'm seeing interesting hacks. Like people would say, oh, don't put when you put something out into production, when you put something out into the world, put it in the instruction free mode, meaning you have to have a second model which is trained or fine-tuned with prompts and responses where there are no explicit instructions like question, answer, question, answer, question, answer, but ignore the instructions like do this specifically or imagine you're doing that and then answer it in this way. So although the instruction-based LLMs are sensitive to prompt injection, people say, I'm seeing that trend now that people say, well, yes, but when you put something out into production, switch out the model to a instruction-free model, which has no instructions ever. It has never seen instructions, but you have to fine tune it. You have to at least annotate the data set and remove the instructions while fine tuning it. And that is generally insensitive to these injection attacks. So again, that is a burden on the developer because you have to have like two models now. You have to have a training model which takes instructions and then you're cleaning up all the chat transcripts to remove the instructions and then fine tuning it with an instruction-free model. Those might be interesting, but those would limit the expressiveness of these LLMs. That would limit the weirdness of the LLMs, but it might be what is needed for safety and reliability for enterprise applications. That's a very common trick I'm seeing. One other thing that I'm assuming is going to happen now is visualization of these LLMs areas of competency. So, I come from this very traditional statistics approach where given a data set, given a model, we first try to ask, well, what can the model express? What is its competency in, what are the typical things it can do? So there are typical sets, there are atypical sets. And this becomes a statistical problem. So you generate lots of outputs, you probe it in many different ways, you generate typical answers. How do you visualize it? Right now, the visualization aspects connected to LLMs are super limited. I'm really not seeing any sophisticated visualization of an LLM's internal capacity. In that respect, there's two ideas that come to mind. And just last week, I saw a blog from AWS by Stefano Savato, who used to be faculty at UCLA, maybe still is. And I used to track his work way back in grad school. He's beginning to say similar things. So many, many years ago, like back in the 80s, there was a field of work called grand tours and projection pursuit techniques, where if you have a high dimensional distribution, and this was in the 80s when high dimensional distribution meant 10 dimensions or 20 dimensions, and you had to get a sense of how complicated the shape of the distribution is to get a sense of how hard machine learning is going to be. People started investigating projection operations onto, let's say, 2D and 3D, but creating a sequence of these projection operators. So it looks like you're taking a grand tour along the distribution, but you're generating sequences of 2D plots. But in a way that is smooth, that is consistent, so that visually you get a sense of where the hardness is in that distribution. Where are the typical sets? Where are the atypical sets? Where are the holes? What is the support set of that distribution? Those ideas were very popular when machine learning was in its infancy. Now I'm seeing a need to revive those methods for LLM type of situations where the dimensions are way higher and it's very, very difficult. Like word encodings are vectorial, we get that, but the meaning of a word is never really encoded anywhere. The meaning of a word is connected to the context it appears in, and then the probabilities of what might come after given what has come before. So the meanings of words are never really encoded anywhere, even though words may have specific encodings based on co-occurrence. And then sentences have their own separate encodings. So if I were to try and visualize what are the typical sets for an LLM? And to me, that would mean, let's say you did not have any adversarial injection happening in the LLM, but you're just looking at normal chit chat and what are the typical types of questions and responses it can generate. To me, that's a visualization problem. If we can take these sentence vectors, if we can take these word vectors and try to ask the grand tour question, let's take a grand tour before we do anything with it. How do you do the visualization? that there are solutions in the past. I think they have to be reinvented for LLMs.
Of course.
Then you start asking, all right, if I were to probe it in that space, what does that question translate to? Can I go back from the latent space to the question, which would be closest to that latent point? That will begin to give us a sense of types of questions that, the types of questions that you can probe it with is infinite, really. And right now, people are just thinking them through, right? They're being creative. They're being very creative and, oh, let me embed an instruction inside of a request for a Python code. So there's all these things people are making up to probe it. But that can be done much more in a more principled way if we take recourse to these distribution visualization techniques and asking, I want to make a question that's out there. Make that question first, and let's see what that question looks like. So that is, to me, very interesting. So the recent AWS approach by Soato says similar things. He says, look, if you have a question and you're looking at potential completions, the interestingness of that question or the meaning of that question is encoded in the trajectory of outputs that it can generate in that latent space.
Correct.
And if we can compare trajectories to trajectories rather than one output, one output is super specific, but if we can get, let's say, the top 10 outputs, and that's a trajectory in the latent space, how do we compare these LLM trajectories so that I can then begin asking interesting questions about how out there is a question and how adversarial is a question? So those are, again, concepts from dynamical systems theory, visualization of high-dimensional data streams. Those, I think, will be very useful toolkits in addition to the guardrails that you're building. Yeah.
Yeah, I think very interesting. I think so just taking the discussion forward on another very important problem statement, which is drift, right? Means obviously LLMs are trained on huge amount of data, but the questions they see are like also can be right from anywhere, right? And so we always see that LLMs have drifted, right? Means so that's one of the big problem that we see today, right? Would love to hear your thoughts on this important aspect.
Yes, I mean, if we think about drift, I mean, drift can be thought of in a few different ways. One is the types of questions that are drifting, right? I mean, we start with standard questions and then suddenly they become adversarial. So the types of questions are drifting. Or we can say we are continuously fine-tuning an LLM and the things we're fine-tuning it on is constantly drifting. So there's going to be interesting problems associated with either one. If you're talking of fine-tuning it, right? I mean, like the real data distribution is shifting or the real use case is shifting and we're trying to adapt an LLM to what's shifting out there, you run into problems of data forgetting. You forget the past, and then how much do you weigh the new information versus the old information? There aren't easy answers, but what we are finding is one is, of course, data adaptation. The other is knowing when to not adapt rather than forcibly adapting all the time. So there's going to be some notion of, I mean, people talk about human feedback, right? There is a relevance human, RLHF, reinforcement learning with human feedback, where once in a while someone can go in and put in a label that, all right, this is fine, adapt to this question, or this is a good question. To me, that is a good framework. But again, it also suffers from this notion that underlying that little human feedback is yet another reward, generator model, which is getting fine-tuned by that one little feedback. So it's, again, a model on top of another model. There is your LLM, and then there is the reward model. So the answers tend to be stacking models again and again and again. That's very common. But one other approach you could potentially take, which is things we are pursuing in my own research, not necessarily for LLMs, but general image types of tasks, is to structure latent spaces with some knowledge of the phenomena that they're trying to account for. In the case of image and video, let's say, we understand a lot about how the physics of image formation works. We understand how shading works. We understand the complexity of the image space under, let's say, what are all the lighting, if I were to change lighting in all different directions with multiple light sources, what is the possible variation you would see? There are some classical results like that. Or what is the manifold of objects that would appear if I were to just rotate an object in 3 dimensions? There are classical results like that. So we are going back to those old results, which bound what is possible in the latent space and image space, but encoding those structures is not always direct, because that type of math that results in asking that question is not always a linear constraint, or it's not always a differentiable constraint that you can just drop in. So you have to find a way to relax that structure in a way that is differentiable, that is efficient. But every time we do that, every time we've encoded some notion of physics into the latent space of an image classifier or an image generator, we find things get better, that it reduces hallucinations, it is robust to drift, it can ignore drift things if I say the latent space needs to be like a circle because some physics constraint said that, and suddenly if the data drift is asking that circle to deform to a straight line, it will not do it because I have a serious constraint in there. I mean, the constraint is not hard. There is always some slack around it, but it would prevent a circle from becoming a straight line because the data was drifting. So we are putting those types of guardrails, which are at the latent space level, which are motivated by no knowledge of how physics works. In the case of language, although I'm not a linguist, but I was taking classes on automata theory, and I was reading old books by Noam Chomsky and classification of languages and going from regular expressions to grammars to stochastic grammars to things like Petri nets. We did work on imposing those types of structures in complex visual reasoning tasks. If you were to explain a scene as either a Petri net or a grammar model, and try to ground those concepts in the low-level stuff, you get robustness to data drift because you are kind of abstracting out the low-level variation and there is a symbolic version to it. So this neuro-symbolic integration is very active. There aren't any quick solutions that I can think of right now that work at scale, but that may be helpful for language models because right now the model of language that is at the root of an LLM is really autoregressive models with very large context vectors, right? Very large context lengths. That is not how language gets talked about at all in the old ways. So while it seems to work, it might be worthwhile to try and structure those latent spaces in some way that is motivated by a stochastic context-free grammar, for example. I don't know how to do it, but those would be directions I would investigate. Yeah.
Great. No, I think that's very interesting. Means we have been using some of these approaches already, right? Both for drift and guardrails, right? And some of that is already released in open source today, right? I think so. I think this has been a very interesting topic of discussion, right? Where we see from customers who are trying to basically deploy LLMs and GenAI at scale. Yeah. I think another very interesting topic is adversarial attacks, right, on LLMs, right? How do we ensure, like for example, prompt injection? Right? How do we ensure reliability of LLMs, right? If we are deploying LLMs at scale or GenAI at scale, right, and we are making important decisions, right? They are open to adversarial attacks, right? Like any other software, right? So how do we avoid basically these kind of attacks, right? And how can we make our LLMs more robust and reliable and GenAI most robust and reliable against these attacks? I'd love to hear your thoughts on that.
Yeah. So again, my opinions tend to be at the latent space level, that we have to structure the latent spaces in a way that are either insensitive to adversarial attacks or can flag them because they were not in the expected pattern in the latent space or from the expected distribution in the latent space. However, yes, the problem is the adversarial portion of your prompt is often so tiny that the equivalent in the imaging world is, a couple of pixels were corrupted and suddenly the decision flipped. So yes, again, there will be this intermediate stage where you would have to make a specialized data set that encodes all these adversarial different variations of attacks and train an adversarial detector itself to flag it as an adversarial attack. That would be a way forward. That would, I think, will keep the community very active and busy for the next couple of years. We have had a very different tack on it. When it comes to adversarial attacks, there is recent results in the past couple of years, at least in imaging, that said, you don't have to have a very sophisticated adversarial detector. What you can do instead is to transform the inputs. So there are these input transformation methods, which are delivering nearly the same performance as very sophisticated adversarial detector types of methods, where the idea is very simple. If it were an image and it were adversarially perturbed, let's say, people would say, well, just compress it a little more into the JPEG format and then recover the picture and see what happens. And people are finding that even simple input transformations like that, rotate the picture just a little bit, or just compress it a little bit, or blur it a little bit, and then use it, that delivers a bunch of robustness to adversarial attacks. In the case of language, that would be an interesting question to talk about. If someone were to write a big prompt, rather than take the prompt as is and respond to it, could you transform the input in a way that is the equivalent of rotate a little bit, blur a little bit, compress a little bit? So how can you summarize it in some other way that keeps the essence of the question, but that adversarial perturbation is either gone or it's, at least written in some other way that doesn't break the LLM. So to me, the input transformation methods would be very interesting for text. In image and video, there is a lot of literature on what those are, and they range from compression, they range from downsampling, blurring, all kinds of things, and they are shown to work equally well as any other method. For text, I have not yet seen what it should be, but I'm going to guess that rephrasing it, like if you take the same prompt and ask your own LLM, just rephrase it in fewer words, it probably might get rid of the adversarial injection, or it might at least reduce its emphasis on the whole thing. I think I would be very interested in those situations. Yeah.
Very interesting feedback. Means in this package that we released today, means we have basically offered a range of matrices, right, for LLM evaluations and for adversarial attacks, right, how to basically detect those and prevent those from happening, right? So a very interesting topic that we should definitely go deep dive at some point of time in future as well. So Pavan, I think has been an amazing discussion. We are getting a lot of questions already. Actually, some of the questions have been addressed by Rehan, who leads our data science, and Jigar, who leads our product. But at this point, would love to get some questions and let me just check. I think we are seeing already a lot of questions. Yeah, let me just pick some of those. So one question here, Pavan, thanks for your time. What are your thoughts on explainability from a research perspective and overlays of machine reasoning? What do you think are the techniques that the community is thinking about? So any views, Pavan, on those?
So explainability, clearly, people mean a bunch of things when they say make it explainable. I've seen a bunch of solutions. Explainability is one of those things that is different depending upon who is the audience, who are you explaining it to? In the case of, again, different media types are explained in different ways. In LLMs, when you say, here is a question, answer it, but explain it, you're really, trying to go back to citing, data sources and trying to do step-by-step, instructions of how you reason there and how you got there. So it borders the reasoning literature, right? That, oh, there are a bunch of logical rules, and I'm answering your question based off of these rules, right? Then the question becomes, well, what are those rules? Are they expressed as first order logic? Are they expressed as, I don't know, linear temporal logic? So you can go deeper and deeper into how knowledge is represented and ask LLMs to express your knowledge representation first, and then reason as to how you got to that answer, and you can flag, automatically whether one of the steps was wrong. So that would work for LLMs. And I think it is going further down into the formal language and formal specification side of things, where it's all about express your knowledge first, what is the world made of, what are allowed operations, what are allowed things, and then reason from there. That will be very interesting to look at, the convergence of formal specification methods and LLMs. When it comes to imaging, a whole other approach is pursued for explainability. It's more about visualizing feature maps, visualizing feature activations. If you say something is a car, how do you know that? So can you visualize the boundaries of the car? Can you visualize the paths of the car? The linguistic ways of working with information have not always succeeded for image and visual media, because not everything in visual media has a linguistic counterpart. And so that often goes in a different direction. Explainability in imaging is very much about, can you trust someone's decision because they're paying attention to the right parts of the scene? So there's a whole, thing on how do you explain these things visually. In other media, even less so. Like if you look at time series and sound, that's even less developed. So this field is very nascent. But yes, there will be a huge role of the formal methods approach of talking about reliability and correctness of things. And there is also this mathematical reasoning approach, right? Where can you make a proof of a theorem automatically? I forget what that subfield is called. It's called automated proof techniques or something, right? So there is all those things also which will begin to play a role for LLMs, and I'd be happy to see where that leads. Yeah.
All right, sounds good. I think there are a couple of questions on Raga. I'll just quickly address those. The RAG applications of LLMs are obviously highly diverse. So how do I build confidence that the LLM testing metrics that RagaAI has released are applicable to my use case? I think so. We have done. I think that's a very important question. Means what we have released, we have put a lot of thought and research into that in the metrics that we have released. We have tested that across range of data sets and use cases, working closely with whatever is available and working closely with customers, right? And this is an evolving area, right? And so we continue to invest on that, right? Make sure that what we're offering is the best technology available. I think there's another question here. Is artificial intelligence still automating the work and we are still having a room for creativity like in the form prompt engineering? That is asking creative questions and will always have that edge. Yeah, go ahead. Pawan, what do you think? Yeah, interesting. Yeah.
It's a great question. I mean, I don't have a clear opinion because I do think some things are, some jobs clearly are a threat. But what we keep finding is there is a growing need for people who are at the intersection of being able to, do prompt engineering, but also have the domain expertise to know how to do that. So while it's a creative skill to do prompt engineering, the demand is to be a prompt engineer who knows the field, as opposed to someone who just comes in with no training in that field. And by field, we mean that domain application. Like if you're going to do an LLM for the aerospace industry, you better know your aerospace knowledge. So there will be a demand for domain experts who are comfortable prompt engineering with LLMs. I don't know if there's going to be like a blanket prompt engineer with no specialization. That would not work, in my opinion. Even though there are I'm seeing jobs like that. Let's say, yeah, we just need a prompt engineer. But I do think domain experts will increasingly take on that role. They will get familiar with LLMs and they will know how to work with, guardrails. They will know how to work with the tools like RagaAI is putting out, and they will be in demand. So people with legitimate expertise in the field. Yeah.
Yeah. I think there are a lot of questions. So I think we'll continue to answer. We have a few more minutes remaining. I think there is question on, hey, can RagaAI help me with golden dataset generation? Yeah, means we talked about that. We are already working with many customers to do that. That's something we have not released, talked about publicly. We'll do that soon as well. That's a very important area that we focus on. This question, a great webinar, Pavan, spoke about latent spaces. Could you speak more about latent spaces in the context of learning on language learning? I understand how at the level of individual tokens, the model can learn the latent representation through embeddings. Could you shed light on how latent space representation could happen at a semantic level, at a slightly higher level of phrases or so on? Yeah.
Yeah. Active research question. I would suggest looking at, I can share that blog post with Gaurav if you'd like to share it to the attendees. So one way to do that is, look, phrases and sentences can be seen as sequences of these tokens, right? There are these sequences that emerge in latent space, for example. So you have to encode semantic similarity as measured by sequence to sequence similarity in that latent space. When you go down the sequence to sequence similarity problem, that's a very interesting problem because sequences can have different lengths, right? One sentence might have 5 words, another might have 10 words, but they may be very semantically similar. So how do you encode a 5 sequence versus a 10 sequence? How do you measure similarity? It's not an unknown problem. It's a well understood problem in time series analysis. There are ways to deal with differing lengths. There are ways to deal with differing placements of the important parts. Things like dynamic time warping come to mind. Dynamical systems theory exists where you encode the time series as if it has been generated by a low dimensional process. I don't know if you are familiar with notions like chaos theory methods. So even if you don't want to model the underlying generative process, there are ways in which you can think of the generative process as coming from what is called a attractor. And if those attractors are similar across 2 sentences, you could potentially say they are semantically similar. So a lot of interesting work exists in time series modeling. which might come very handy for exactly this question. How do you measure at the phrase level, at the sentence level, notions of similarity and meaning? Yeah.
No, thanks for that. Just going on to some questions. Yeah, does Raga also work with data privacy sensitive clients such as federal or defense? I'm interested in the AI platform for individual organizations as well. Yeah, of course. Means we are already working with several data sensitive verticals and clients. So an enterprise version that we offer is targeted towards that, right? So please reach out to us if you have basically a requirement like that. I'm Alex. I'm currently working at a small startup and looking to get into automated chat assistance using LLMs. Can I build a comprehensive testing pipeline using open source version? Yes, very much. But if you want an enterprise platform for scalability, please, you can reach out to us, right? And it runs on-prem, just to answer the question that is being asked there. Um, can Raga LLM test and metrics help you with regulatory guidelines in healthcare industry? I think next step of testing is compliance, and we work in industries like healthcare, automotive, aerospace for the compliance part. So please reach out to us. Any ideas given the input output pairs samples like few short learning for LLMs in ICL? Is it possible to find the right prompt or suggesting prompt? Any question, any feedback on that?
Would ask a little extra information. ICL meaning what exactly?
Giving the input output pair samples like what is a short list? So like few short learning for LLM in ICL. Is it possible to find the right prompt or suggesting prompt? I think it's not very.
I see. Okay. So, right, if you want to get a few prompts to fine tune, so don't have a clear answer other than there is a machine learning core problem which used to be called active learning, where the goal was how do you get the least amount of new samples labeled that provide the most information for the learning or adaptation task. You have to make some assumptions. Again, it goes back to what is the complexity at the latent space. Very intuitively speaking, if it were a classification problem, they would say, oh, the most informative samples where you want extra information on would be at the boundaries of the classifier, which assumes two things: that you have a base classifier to begin with, and the boundary you can probe, right? You can, if I pick a point in the latent space, I have a way to go back to the input space and create the picture, for example, for that point. Those things would be interesting for LLMs. In the context of LLMs, we don't really think of them as classifiers. So the latent space is like complicated because it's not like we're trying to split it into K categories, right? So these are really auto-regressive models. Words have embeddings, but it might be interesting so the boundaries of an LLM might just be the so-called the hull, right? If you were to somehow be able to encode typical sentences, it will require us to understand what are typical sentences in this LLM and somehow get a handle on that embedding. Then in that embedding space, we could say, and we could go to the boundaries and say the most informative samples would be that are close to the boundary and probe them. So that would be my approach. Yeah.
That's great. I think we can just take a couple of more questions, and we have like a lot of questions coming in. What are you building next at RagaAI? What's your roadmap? Yeah, I think we are very much focused on making sure that we are providing a comprehensive evaluation, testing, and guardrail platform for different kind of AI, multimodal AI, be it computer vision, LLMs, or structured tabular data. There's a big effort on enabling LLMs from POC to production. I think that's a big area of focus for us. Compliance, data generation is another big area of focus for us, right? Moving forward, we'll talk more about that in public domain soon. So I think that are some of the very exciting areas we are working on. Let me take some of more questions here. Adding to active learning, how far are we from brain-like computing where we human do not need a lot of data labels to learn? Today challenges are high level data in any supervised learning to GenAI using latent space regression is one specific. So any comment on that, right? How far are we?
So it's very hard to answer that question because look, the rise of ML and AI that we see today is only very weakly inspired by how the brain actually works, right? I mean, even though we say neural networks as if it's the brain brains don't really work that way, right? I mean, and then people say, all right, we'll model it even better with things like spiking neural networks. So there is this attempt at mimicking the brain. But the other thing to know is our brains are, they say it's not like our brains work in isolation. It's not like input comes in, output goes out, right? I mean, we are actively present in the world. We have multiple senses we are working with. We are fully embodied. We don't yet have an embodied agent that we can show as, oh yeah, that's where it's going. Of course, you can say, well, let's embed some things in a robotic platform and let it work with the world. So the more things get embodied, uh, the more interesting it gets to how humans actually learn. But then it's still, there are so many unknowns about how memory gets encoded. We don't really have a handle on memory in AI. We don't really have a handle on, like we are born with all this knowledge about simple things. And it's not like we are born with no knowledge. That's not, and we just learn. That's not how it works, right? We have some bias already because of evolution. We don't quite know how to encode that into neural nets other than maybe pre-train a classifier. That's at best the evolution we can think about. So there is a very interesting talk. I'm happy to post that TED talk also by someone at MIT who shares my first name with a W, Pavan Sinha, who is a neuroscientist, but also an electrical engineer, but became a computational neuroscientist. He did a bunch of experiments with children who had congenital blindness, for example, but for a curable reason. So, for example, a cataract that just went undiagnosed because they were born in a small village. So that category. So people with curable blindness who had gotten to age 10, 12, but they didn't know the blindness was curable. So he would go and find those people, and this was all in India actually, and he would cure them. I mean, he would take them to a hospital in New Delhi and free operation to remove the cataract. And then you can ask that question: how do humans learn to see? Because now you can ask the child actual questions. What do you see? How are you? The child can actually respond now.
Yeah.
So a lot of interesting data came out of those experiments, and this is what they found, especially when it comes to visual learning. It's hard to talk about it. You should see the videos. They would show this kid who has been operated on 1 week after surgery. So their vision, when you ask them, what do you see? They say, oh, we just see, bright dots everywhere. Like they don't see objects. They don't see outlines. All they see is bright things. So a very super pixelated scene is what they see. And after a week, another week passes, then you ask, what do you see? And then they start seeing boundaries. And but they still can't name objects. You have to train them to name objects. But they see really odd types of objects. Like if you have a circle intersecting with a square, they would say those are three objects. They would say this part of the square that is outside is one object, this part of the circle which is outside is one object, and that intersection area is a third object. So they would over segment the scene. And if you showed them a real picture with a shadow, they would say the shadow is its own object. So there is the cow, and then the shadow is its own separate object. If you have a multicolored thing, like a cow with stripes, they would trace out every stripe as its own object. So they still don't have a sense of what is coherent in that scene. By week 3, things have changed, and they can see full objects. And they say how. And they were able to experiment on the mechanism, and this is what they found. They said motion, that if you take this overlapping circle and square and you provide an independent movement to both of them on a screen, immediately you have these cues of coherent movement kick in, that, oh, all these pixels on the square actually move together, and all these pixels on the circle move together. So the intersection is actually not an object. It's just the overlay of the circle and square. They can reason it out. That happens week 3. So their whole finding was human visual learning doesn't happen by seeing a bunch of pictures and labeling them. Human visual learning is significantly modulated by movement in the scene. And movement doesn't have to be in the scene. You as an agent can move, and your movement induces movement on your screens, right? Your retinas. So motion, movement, and that only happens because your brain is in a body that can move. So motion is extremely critical for how humans learn to see. So if you see that video, you will see all the advances in GenAI ML as completely disconnected from that knowledge. Like there is what movement is happening in ChatGPT or even DALI. Yeah, the video generation, maybe there is some notion of movement there. But the way we have constructed neural nets right now are very weakly inspired by biology. So I don't quite know how far we are. We may be very far yet.
Thanks, Pawan, for that insight, and thanks a lot for very interesting and exciting discussion here on a very important topic, which is Gen AI, LLM evaluation, and guardrails. Right. So really thank you, Pavan, for all your time and your insights on that. Thanks a lot for all the participants who have joined. Basically, today, as we discussed, right, we open source RagaAI, open source the LLM evaluation and guardrail with over 100+ matrices. Please try it out. You can go to raga.ai and basically look at our LLM page, and the packages are available on GitHub. Right. I think so. So this is something which is very exciting. Would love to hear your feedback as we go on. We do these webinars on a monthly basis at least, so would love you to basically join us. And if you have any questions, please reach out to us through. There are opportunities on our website to book a demo, or you can reach out to us on our LinkedIn profile. Happy to answer those. Thank you, everyone. Sorry we are not able to answer every question, but really appreciate your feedback on this. Have a great day. Take care. Bye.
Thank you, Gaurav, and thank you everybody for joining. I appreciate your time. Thank you.
Thank you.
Yeah.
Bye-bye.